So just by a quick show of hands, who in here is familiar with blockchain? As a technology, not necessarily Bitcoin, but truly blockchain. Okay, so didn't see a lot of hands go up. So what we're going to do is we're going to stay up high, and then we're also going to go down low and get into the technical area as well. And so just as a brief introduction, as Dale was saying, well over 20 years in the telecom space, mainly focused around IoT and machine-to-machine. Helped build and develop the partnership program on the Verizon side within the South area and also in the Central Texas region. And so within that, I worked with a lot of small companies that were bringing very innovative devices to market and needed connectivity. And so we kind of built the ecosystem around how do we help and enable all these people building devices. So everything from certification all the way to marketing, go to market, bring them in as part of our data road shows and things of that nature, and really give them the exposure that they need and deserve. And so from there, kind of took the passion from the ecosystem side of things and started incorporating more services into what my focus has been, I guess I would say over the last 2.5 years, which is really around how do we enable connectivity in a secure manner, and also the data that's going across the communication channel, which led me into blockchain. Actually is one of the companies that I advise today that has already gone down the path of blockchain. And I have 2 other ones that we're investigating whether it's a good technology for them to use or not. So the reason why I was asking about Bitcoin versus blockchain is because I really want to focus on the enabling technology, not necessarily the protocol itself, but we're going to go over a brief history of that as well. So out of today, this is kind of what I'm hoping that you get out of it, at least something of value, whether it be the definition, what is it made up of, some of the value, what is the current landscape of distributed ledger technology of today, not necessarily just blockchain. And then we're also going to do a live demo. We're going to do 2 different demos that are actually live on the internet that you'll be able to go to yourself and kind of refamiliarize yourself. The first demo has actually got a 17-minute video that walks you through it. So if you don't catch something today, it's not a big deal. You can go back and look at the video, and he walks you through exactly what we're going to do today again. And then most importantly, I want to talk about some of the use cases, which means that it's not necessarily implemented in that way today, but then also some of the case studies which are true implementations of blockchain and where it's successful today outside of cryptocurrency. Okay? So, any questions so far? Yes, sir.
Yeah, I was interested in that phrase you had on the first slide, accelerated technology. Consulting, yeah. Who?
Yeah.
Accelerated.
So, it's...
Could you explain that?
Absolutely. So the whole purpose behind it was really kind of a philosophy that I had on the Verizon side, or adopted when I was at Verizon, and that is, how do we take somebody from ideation to market in the quickest amount of time with the fewest steps, and also most importantly the least cost. And so in that there were a lot of tips and tricks that we learned along the way, a lot of Lean Six Sigma type of implementations of our processes to make everything more efficient. And so really that was kind of at that time is whenever it became part of my core DNA, and that was around 2010. As how do we accelerate things? How do we get things to market quicker?
Which is spelled differently.
It is spelled differently.
Now, so is that a reference to the spreadsheet? Or?
Well, that's exactly. So anytime that you see something that's spelled differently, there's always an attention getter. So I'm really big on neurology and psychology when it comes to marketing, which I highly encourage anyone in here to endeavor into that, learning a little bit more about it. But it's more of an attention getter than anything. Okay. And then you'll notice the puzzle pieces. Those were strategic because of obviously putting multiple people together to create the solution. So as somebody mentioned earlier, one person doesn't know it all, but if we get a room of people around us together, then eventually we solve the problem. So what is blockchain?
It's a quick question. Do you think Six Sigma is not faster enough for you?
What do you mean?
I mean, you said Verizon and Six Sigma use Six Sigma, and so do you like Six Sigma in terms of the speed of delivery or not?
Sometimes, well, I would say Six Sigma is really used, from my opinion, is on existing processes to make them more efficient or to lean them out. there's many different adoptions. There's lean startup. There's, which is really talking around how do we keep everything in a bootstrapping type of a manner through to revenue. So I would say there's different iterations of what I would consider to be lean, not just the Six Sigma side that Toyota implemented. So, but yeah, I do agree with quite a few of those. And I would say one of the primary use cases that we always talked about was airlines. If airlines didn't use some form of a Lean Six Sigma type of an environment, then we'd be a little more apprehensive to get on an airplane. Yes, sir.
Wasn't Six Sigma originally intentioned to develop reliable systems, but now you're talking about making lean systems?
Both.
Was that an add-on to the Six Sigma process?
So eventually, in the beginning, yes, you're exactly right. So there's been different iterations for different purposes, and I think that's where everybody kind of puts their own spin on Six Sigma. So on the lean side of things, yes, it was to make everything more efficient and reliable. I would say reliability first, but efficiency on the second side. So how do we cut out all the nonsense to make it more reliable? Really is kind of the core philosophy behind it. Okay? All right, so if you've looked up the definition of blockchain on the internet, you're going to get a million different responses that all say something very similar to it. The one that I like the most is the one that comes from Don Tapscott. And it's really just the fact that it's incorruptible data ledger of economic transactions. We'll get into what economic transactions mean in just a few minutes. That can be programmed to record not just financial transactions, but virtually anything and everything of value. I added the anything in there because anything could be the fact that I wanted to secure that as a digital asset. That's now possible through blockchain. So where did it originate? How did we get all this stuff going? Because I know that, if I ask how long ago was it that somebody knew the term Bitcoin, it probably was only within the last couple of years that you've heard of that or even started seeing the icon. Reality of the matter is, it was launched as a white paper back in 2008 by a fictitious character or group of characters, we don't know, called Satoshi Nakamoto. The white paper was launched onto a cryptography forum or a blog where people kind of started understanding a little bit more about what can we do to solve in computer terminology. This is actually a hyperlink that you can click at a later time, but to solve the Byzantine general's problem. And it was really around how do we set up shop around an enemy camp. I've got all my generals with their teams that are surrounding the camp, and we're analyzing what is the enemy doing inside the camp without them knowing that we're there watching. So in that, you can imagine, I don't have a cell phone to call. I don't have any other method of communication other than messaging. And through that messaging, I have to also gain a consensus that all the majority of the generals that are around are going to agree on the exact same plan of attack whenever we go in to attack the general or the enemy. And so it's a very interesting thought process, and that was really kind of the whole premise behind how do we do this with security of data. So if I wanted to be able to walk up and hand somebody a $20 bill, I can do so without them knowing who I am. I can do that without knowing who they are. And there's not any form of an obligation from either person in doing so. I just wanted to hand somebody a $20 bill, and I wanted to go my own separate way. So how do you do that in the digital world? Because with PayPal, just as an example, not to pick on them, but as an example that's very familiar to everyone, you have an account, you know who you are, the person you're sending money to knows who you are. They either send an invoice and request it, or you just send it to them as a gift. And so all these different things require that there's no anonymity.
Close.
Close. There's not an anonymous transaction. Let's make it easier. And so in that, how do we make that an anonymous transaction in the digital world is really kind of where this started coming from and kind of where Bitcoin built from. So back in 2008, the white paper was released. Bitcoin as we know it today was actually birthed around 2009. One of the core developers that was actually a Google developer, he first picked it up and was the first exchange between Satoshi and himself, had tons and tons of Bitcoin within his wallet. during this time of interaction. And there was several different interactions that took place, and then all of a sudden Satoshi just disappeared. Nobody's ever heard anything from this group or character since that time.
He went off grid.
He went off grid, literally off grid and off chain.
Where
And
is he now? Is he still alive?
nobody knows, because
That's
nobody knows
what
who he
I heard.
actually was. He literally, Satoshi could be sitting in this room for all we know. I have no idea. Nobody does.
I think he gave one interview.
He did what now?
He gave one interview.
Did he?
Yeah, no, it's there in the Bitcoin documentary, like now what's on Netflix. He gave an interview, but he said this is going to be the last one.
Really?
Yeah,
Is it on Netflix?
but he's not a Japanese, he's a white.
His wife?
Interesting.
Yeah, he's on Netflix. Yeah.
So the question I would have at that point is, does anybody ever watch Top Gear and know who the Stig is? Okay, so Ram, who else? Anybody else? All right, so there's a TV show where, just really quickly,
Oh, the British show?
the British show,
Right, yeah.
right?
yeah.
And so there's this race car driver that you never see him without his race suit on, without
Right.
his helmet on.
Stig or something.
The Stig, exactly. You never know who he is. But there's been different people along the years that have said, well, I'm the Stig. And so it became kind of a joking community, that, I am who nobody knows. And so I'd be curious, I'm gonna look it up because I'd be curious just to hear how they talk. So second to that, and this is really where it gets exciting and kind of the focus for the rest of the talk, is really based around the Ethereum protocol. So Bitcoin is a protocol, Ethereum is a protocol, and there's many others that are in development right now as well. Might touch on those if we have time. But in 2013, Vitalik was actually born in Toronto. Yes.
What is the difference between blockchain and Bitcoin?
So Bitcoin is the protocol that runs on a blockchain network. Great question. So think of, and I'll get into the details, but just think of blockchain is the cellular network, but the text message that you just sent is Bitcoin. So it's a protocol that runs on the top of that particular network. And so everybody just associates the two as one, but in all reality, they're very, very different from one another.
So is it blockchain that gives the reliability of the transaction?
Yeah.
Correct.
Right.
Well, yes and no. And I'll get into that because truly it's the protocol, which would be Bitcoin, that gives. So whenever you look at building each one of these different tokens or these different currencies, however you want to look at that, if you're doing something that is your own protocol, so let's say that Bitcoin is TCP and Ethereum is UDP. They're protocols. And so within that, I have different standards that I can do and use different ways. So they each one have a different purpose, and really in the business versus consumer side of the world, they become extremely different. And that's where we'll get into that. So Ethereum, Vitalik was actually one of the early adopters and developers for Bitcoin. And back in 2011, if I'm not mistaken, he saw a lot of the shortcomings and he wanted to build something that was more business focused, enterprise focused, something that was going to help the betterment of business and not necessarily focus so much on just transferring money back and forth. So the thing that becomes very interesting is actually we had a quick conversation. Vitalik at the time that he, and there's three others as well, I don't remember their names off the top of my head, that developed Ethereum. The kid was 19 years old whenever he came up with this whole concept and wrote the white paper. It obviously released in 2013, but he was 19. And I'll tell you, if you ever have the opportunity, or I would encourage you to make the opportunity to watch some of his interviews, because it's unlike any other 19-year-old that I have ever seen in my life.
Other than perhaps Isaac Newton when he
Well,
came up with the calculus.
That's true. Of modern time. I would say he's the Isaac Newton of modern time. It literally.
Albert Einstein, he did that 19 or 20, he wrote those theories of relativity.
But they didn't get solidified until many years later, actually early 1900s.
But when he was 13, he wrote the proof for the Pythagorean theorem on
Correct.
one page.
That's right.
Instead of the many documents, pages that
Absolutely.
it was before, right?
That's true.
Yes.
And so, it's just, this would be what I would consider one of those modern day Einsteins. It's unbelievably brilliant how he understands economics, how he understands business, how he understands, it's just, I'm just telling you, most definitely worth going and checking out. So,
And he is, no, he's still alive. People-
oh yeah, absolutely, yeah. I mean, he actually, he most recently, one of his claims to fame is actually he had a private meeting with Vladimir Putin to talk about using Ethereum as a cryptocurrency within Russia. And so to kind of give you an idea of what kind of status this guy has, just on a global scale, and just extremely down to earth, normal guy. I mean, it's unbelievably
Is he
brilliant.
working for a corporation somewhere?
Ethereum.
Oh, his own,
Yeah,
okay.
exactly. So so the Ethereum is, the consortium, if you will, or the nonprofit is based in Switzerland, but he's still in Toronto. And so he kind of runs everything from afar, if you will. So what are the components? The major things, and this is really where we start differentiating and getting Bitcoin out of the conversation and truly talking about the technology itself. So first of all, it's a distributed network, which has some inherent safety and security things built into the fact that it is distributed. One of those is replication of the ledgers. So anytime that you open up a checkbook register and you write down a credit or a debit, that's essentially what's happening in a distributed manner. So think if all of us in here had a copy of everybody's checkbook register, and every time that you write down a transaction, you sent that information around the room and everybody updated their ledger with your transaction that took place. And so with that, now if you go to make a change, or if anybody wants to go make a change, then there's a voting process. And they have to go and basically broadcast, I want to make a change, is this okay? And there's a voting. So before a change can be made, there has to be a consensus. And this is really kind of where the inherent security comes into play on the larger scale blockchain networks. So the bigger the network is, honestly, the more secure it becomes, because you have to have a consensus from all the nodes in order for a change to be made on the network. Not to say it's impossible, but it's a very, very, very strong, heavy use case that has to be presented before something happens like
So you're
that.
saying it's more secure when you have more voters?
Correct.
What happens if you start getting dead people on the voter rolls?
So, good question. There's actually what they call a statement of work or a proof of work, depending on which one you're doing. If you're closing transactions, it's a proof of work. That's also what keeps the spammer. So if all of you guys on one side of the table decide, hey, we're going to do Bitcoin nodes on the Bitcoin blockchain, and we're going to try to sabotage the other side of the room. You have to pay a price to even begin that process, which is called proof of work. So that's actually closing the transactions out mathematically. And so it deters people from trying to do spam on the network and things of that nature. So it's a deterrent, not necessarily a true security measure, if you will. So data stored in the block is up to you. We'll get into that in a few minutes. So these are just very high level. I'm not going to go into each one of these individually. The network protocol itself, this is really where blockchain becomes its own amoebic thing. And what I mean by that, think of it as blockchain is the internet, but Bitcoin is AOL and Ethereum is Netscape, because that's about the era that we're in right now, according to blockchain. So you've got the very beginning players that are at the starting line. A couple of applications have been launched, but there's so many more things that are coming right behind it that it's insane. And I'll talk about some of that in the use case side of things. What it does, though, is it gives a framework. So I have a framework, as you do within any kind of like a scripting language. You have a syntax. So within that, I've got this realm in which I have unlimited possibilities of how I want to change that. So within blockchain, we've already started seeing, I would say probably close to 12 to 15 different iterations of blockchain type technologies. So I would even take it down another level if you really want to get into understanding what's going on. And at its core level, it's really a distributed ledger technology, or a DLT. And blockchain sits on top of a type of DLT. I'll get into that in a few minutes. The use of cryptography. This is where people can, yes.
So When you said it's a DLT, isn't it a contradiction of replication of ledgers? Why, if it's distributed, why do we have to replicate it across all the, why do you have to replicate the ledgers across the blocks in the chain?
So that's actually a good question. So if you're all on the Bitcoin network, which is a public, so I don't want to get too much into that question because I'm going to answer it in just a minute. But to answer it high level, there's public and then there's also private. On the private side of things, you have the ability to do whatever you want to do. So if I wanted to replicate certain things, I can replicate whatever I want to. I don't have to share that with all the different nodes on the network. On a public network, that's whenever it becomes trustless. So I have to replicate all the nodes because that's what causes the consensus on the voting process whenever I go to write a new block to the blockchain. So if I don't replicate, then everybody's not going to have the same. So I have to. It's part of the inherent side of things where I have to do that in order for it to really add any value, to be honest with you. Because if all I did was just copy, then number one, I don't know who all's on the network because only the network knows. I don't know. But second to that is it also, now I can tell whenever there's somebody rogue that's trying to plug a node onto the network and try to sabotage the ledger. I can easily pick them out because there's not the same, they're not coming with the same ledger that somebody else has. Does that make sense? So
what I'm hearing you telling us is that the guy that said that there's an incorruptible system in place to account for value, and you're telling us that the system is corruptible. It's just that there's a high initial cost to whoever's trying to corrupt it.
you're exactly right.
But it can be corrupted.
It has been. So that already has happened, yes.
By North Korea, was it?
Well, I'm on video, so I'm not going to say that. You said that. I didn't say I don't know what you're talking about. So, who said or who did it, who knows? I'll let you do a little research on that one. But, and honestly, there's still theory. It's not solidified who actually caused it. So
There was a very interesting article where people, went up to Google this one of the GPUs because the hashing takes extreme processing. So they've done the reverse hashing on GPUs and cracked of the Bitcoin and Ethereum. So it's actually happening in US also.
So there's some additional measures with the company that I'm working with that actually gets around that from a security perspective, but it's intellectual property. Just know that there are people, well, I know of one particular company in specific that's even based here in Dallas, that they found another way of doing the cryptography to where it mitigates that risk. So it's very interesting. I'm actually excited for him to launch that product because it's going to be.
So is that going to be a protocol, or is it just like a module that you would add to a protocol?
It's actually it's using the Ethereum stack.
Okay.
That's as much as I can say at this point. Yeah, but it is using the Ethereum framework, if you will. It's just using it in a modified way.
Can you name the company?
No.
Okay.
No. So, and then the transfer of value. So really that's what everybody cares about at the end of the day. How do I get value from one place to another, whether that's an asset, whether that's a digital form of an asset, or if it's actual digital currency. And so that's really kind of the biggest benefit is being able to transfer value from one person to another, not necessarily Bitcoin. Okay? So types of implementations. Even this is now changing. Because they've now come up with a third, which I guess we can talk about that a little bit. It's called a hybrid, and we'll talk through some of these. So this is probably what you've seen the most of is a non-permissioned public blockchain, Bitcoin. It's a public network. Anybody can go buy a node. They can plug in. They run the protocol. They become a node, or the stack. They become a node that closes transactions on the network. Anybody can write to it, anybody can read from it. It's a completely open, free network. Now, free
Kind of like
network,
Wikipedia?
something like that, yes. Something kind of, it's free for anybody to use, how about that? but there's, I say free haphazardly because there is a cost on the transaction fees, which is starting to show some very interesting things. On the permissioned public blockchains, this is where we'll spend a little bit more time because there are some companies that are doing permissioned public to where it's allowing multiple companies to benefit from what they're doing internally, but it's not a completely private. So the benefit to that would be, I still have people that plug in, I still have the ability to scale my network based on the number of people that become a node on my network, but I don't necessarily have to allow them access to the data that's on the blockchain itself. So it becomes a very interesting thought process as which one we go through. So as we can see, that's the equivalent to the internet back in the early 90s. Equivalent to what's happening today from an intranet perspective. Is everybody in here is, I would assume, familiar with intranet, extranet, all the different things that we did in corporate America. On the intranet side of things, this is really where a lot of your banking companies are playing right now with consortiums that are popping up. So if you look at the fintech space, specifically within the banks, you've got R3, which is one of the consortiums that's produced a product called Corda. It's a distributed ledger technology, but it's really specifically for transmission of value from one bank to another bank that's a federated bank. So that's really where you would see, a lot of your big corporations that they want to keep their information off the internet, but still have the benefit of blockchain technology. And then on the private side, this is, right now at this point, there's not very many of these on the market simply because of the cost of development. That's really the limiting factor. So if I wanted to build my own network, now think about this. How many of you in here work for a company that have, server farms with maybe 3 or 4 around the country or around the globe? Okay, so not a whole lot of hands went up. So think about the number of you that have only 1 or 2 data centers. That's the number of nodes you have. There's not really a whole lot of security there. And so there's the private blockchains are really more for like your large utility companies are looking at this, your OEM manufacturers on the telematics side of things, like your GM and Ford and those guys. But it becomes what some people are calling the Internet of Blockchains. Was that a question?
Yeah, I was just wondering, could this be implemented to detect configuration changes in the system and have it approved by a blockchain set of voters?
Most definitely.
So that when somebody's trying to mess with your system, nobody would vote on it, or
Absolutely.
you could hunt it down. So it's definitely implementable in that environment.
Most definitely. And I would say that especially on the cybersecurity side of things. So think about whenever you're doing firmware upgrades to your firewalls or your routers on your network. So if I were to, actually you can even look this up. A lot of the firmware packages now, you can encrypt them with cryptography on the firmware side of things. So if your keys aren't matching, now this is just a simple PKI stuff, but if they don't match keys, then firmware doesn't get upgraded. But there's not necessarily a ledger behind that saying how many people have attempted. And so really the benefit to blockchain at that point is not necessarily the cryptography, because that's there today, but it's really the ledger behind it to show who pushed the firmware, when did they receive it, the time date stamp, so to speak, and also the origination of where it came from. That'd be the biggest benefit in that scenario. So the data flow, just quickly, can y'all see this in the back? It's probably pretty hard to see. So really, a request is made. Once the request is made, then the point-to-point networking, which also is known as the nodes, this is where it gets interesting because a lot of people don't understand the voting process. So if I were to say, let's think through this for just a second. Let's say I have 100 Bitcoin in my wallet. And out of the 100, 5 minutes?
Yeah, 5.
Okay. So out of that, how do I know that if I've already spent the money before I make another transaction? So like in a bank, you swipe your card, they immediately know you spent the money. You can't go to the next store and try to spend that exact same money. So everything gets put into a queue, which is held until everything gets validated and written to a block. So that's kind of one of the mechanisms that they've gone through to keep people from being able to. So if I've only got 5, let's skip the flow side of things and show you an actual. Why are we? There we go. So this is the demo that you'll be able to go back and watch the video at a later time. So the way things start off, and I'm sorry if it's hard in the back for you guys to see, but everything starts off as a 32-bit hash.
It's hard for us in the front to see.
Well, so within that hash, obviously the data that you